So, in this dairy and food process and products technology class, this is lecture number 50. We will discuss some of the technologies which are used in dairy industries. Of course, this is not only in dairy industry, but also in processing industries they are used, and these new technologies are coming up very much in not only again in dairy liquid food, but obviously in liquid food it is more important, but in solid also some of them are utilized, solid food. But for example, membrane you have to have with liquid food only, right? Membrane processing or membrane separation, by which nowadays you get in every house this water filter, right? Water filter you get, that is through membrane technologies. And in our institute we have our colleagues, they have made this membrane to the level that bacterial filtration is also possible. And not only that, in many cases people are using for removing the contaminants like arsenic, which is very poisonous. So, this is a very useful technology, that membrane technology that is being used. So, that is, let us start with that. Our time is not very high, we are coming very close to the end. So, that regularly as we are explaining more and more, time is also being consumed, but yes, it is a time frame class, and cannot be extended beyond the 60 lectures. So, we have to finish some more very important things. Maybe some products we will also discuss, right? Maybe like two important one. One is your what you get cheese, and another one ice cream. These two products also we can discuss maybe, and then we may have some time to discuss about the general, that control modified atmosphere storage or packaging, that also we can. And maybe for this kind of liquid food, some your packaging, that can also be discussed. We'll try and see as much we can cover up. Okay. So, this is the membrane process, where this is ability of semi-permeable membrane of appropriate physical and chemical nature to discriminate between molecule primarily on the basis of the size, to a lesser extent on shape and chemical composition. What membrane technology is done? Say this is one, we have a membrane, right? So, it will have very fine pores, very fine pores. The finer the pore size, the filtration efficiency, or rather in terms of quality, filtration efficiency is so high, even to the tune of bacteria who are maybe less than microns. So, they can be separated, they can be removed. They are also used for separation of this. So, this membrane technology is a semi-permeable membrane. Semi-permeable means it will permit only one, right, and rest of the things will not be allowed to pass on, right. So, that is what is primarily this membrane technology. Then ultrafiltration. In many of the colleges, this ultrafiltration is also available, right. So, in many of the colleges, this ultrafiltration is also available, and this is also a membrane that allows separation of smaller molecular weight substances ranging from 10,000 to 75,000 daltons molecular weight, right, 10,000 to 75,000 daltons, that molecular substances can be removed with operating pressures ranging between 10 to 200 psi G, right, 10 to 200 psi G. This ultrafiltration can be utilized for separating around 10,000 to 75,000 daltons this molecular mass, whose that is the mass, that is the material or impurity which you want to remove, and that ranges between 10,000 to 75,000 dalton molecular size or weight, right. Then by reverse osmosis, right, reverse osmosis is, as I said, that household these filter things, they are available with reverse osmosis, right, RO, and these RO filters are available, very much popular nowadays, where these membranes are characterized by molecular weight cut of nearly 100 daltons. It was 10,000 to 75,000. Here it is nearly 100 daltons, and the pressure involved is around 5 to 10 times greater than those in the ultrafiltration. Here it was 10 to 200 psi, so it will be 5 to 10 times, so around 50 to 2000 psi. It is pressure is applied for reverse osmosis. So these data are very important for you. So that 10 to 75,000, 10,000 to 75,000, 10 to 200 psi. This is the size where the molecular weight or substances which are removed, and this pressure is around 10 to 25 200 psi, whereas here it is around 100. In reverse osmosis it is around 100 and 5 to 10 times greater than the pressure of the ultrafiltration. Then we see nanofiltration. This nano word nowadays is utilized in many cases. Since it has come, let me, I just cannot hold myself. Whenever new thing comes, at least make it a little open to you, so that understanding in a bigger sense may be easier. Nanofiltration, nano size is 10 to the minus 8, right, 10 to the minus 6 is micro, so minus 8 minus 9 is nano. So this nano is utilized nowadays in many cases, right. Even in packaging industries also, these nanoparticles, they are trying to mix up with the film, so that the strength of the film becomes more, as well the all properties, because it is not only one, many properties are also can also be not only affected, but also be improved towards your requirement. So this nano technology is coming up here also. Nanofiltration, that is, you want to filter very fine one. So nanofiltration is a demineralization process. Acid way can be partially demineralized about 40%, particularly with respect to the movement of the ions, or these monovalent ions. Monovalent ions are also separated and concentrated simultaneously to approximately around 25% total solids using the nanofiltration process. It separates particles with molecular weights in the range of 300 to 10,000 300 to 1000 daltons. So, this 300 to 1000 daltons with nanofiltration it can be separated, and operating pressure requires nearly around 300 psi G. So, high pressure you need for this nanofiltration, and the particles which you are separating is around 300 to 1000 daltons, right. So, this is another technique by which you can separate. Then microfiltration, right. So, from nano we are coming to micro. Micro is bigger than nano, much bigger, right. So, microfiltration is another technique by which you can, of course, as from the word itself it goes that the size will be much bigger than the nano. So, in that microfiltration is essentially used as a clarifying process to remove macromaterials and suspended solids, milk fat globules, bacteria and colloidal particles. These are all with respect to nano macro, right. Though micro, but with respect to nano they are macromolecules. For example, we said suspended solids, we said milk fat, we said milk fat globules, we said bacteria, or we said colloidal particles. All of them can be removed by the microfiltration. Then in microfiltration, membranes with pore size ranging between 0.1 to 10 microns, 0.1 to 10 microns, the pore size of the pore size, again as we said, if this is the filter medium, so these are the pore sizes through which it may pass, right. So, between 0.1 to 10 micron size, and the pressure, operating pressure ranges between 1 to 25 psi G, right, is used. The most significant application of the microfiltration is to separate the bacteria from milk. That is one vital, that bacteria with microfiltration, if that can be removed from milk, then that high temperature which affects the quality of milk cannot be required, or is minimum, can be minimized, right. So, this is another technique by which you can remove even the bacteria from the milk. Then come to some other techniques like ohmic heating, right. So, we have heard the Ohm's law. So, from there we know, rather I should not say we have heard, we know Ohm's law. From there this ohmic heating has come up. That ohmic heating is what is also called the electric resistance heating. So, depending on the because we know that the resistance of the electrical conductors are expressed in terms of its ohm. This has so much ohm, 10 ohm, 14 ohm, 15 ohm or 20, like that, depending on the product, depending on the material. This we say as the resistance of that. So, the resistance of the material, that is the primary or electrical resistance of the primary mechanism by which this ohmic heating is been introduced, right. So, ohmic heating, also called electric resistance heating, is a direct heating method that uses food itself as a conductor of electricity that is taken from the mains. The most important benefit of ohmic heating is that heating is very rapid and uniform. That is another thing, right. Say you have a pipe like this and through which milk is going, and this side is being heated by steam, this side is heated by steam, right. So, it is all likelihood that the milk which are towards the pipe side, they will be heated more than the interior. So, the non-uniform heating may arise, whereas in this case this heating is very uniform, because you are using the food product as your resistance material. You are passing the electricity through that, and that is causing the product to be heated up. So, uniform heating is being made, right, and rapid and uniform heating is being made is the primary key of the success of this unit. The process is ideal for shear sensitive products, right. So, those which are shear sensitive, those products can be very effectively be heated by this ohmic heating method. Then microwave heating, in many cases we nowadays microwave has become one of the household commodity by which you utilize every now and then. In most of the houses, I am not saying in terms of villages may not be this has penetrated to that level, but definitely in the bigger cities or in metros, this is very useful nowadays and people are using. So, in that microwave heating, what primarily is being done, this is what some microwaves are being passed, and then depending on the polarity and there the polarity of the material which is being heated is primary. So, that is why non-polar systems are not being heated or not being used, right, but it has to be a polar where like water, right. So, that becomes heated up, and then that because of its movement it gets heated up and raises the temperature and does the performance, right. So, microwave are a form of electromagnetic radiation characterized by the wavelength and frequency. Microwaves used in the food industry for heating are ISM, that is industrial, scientific and medical frequencies, which are around 2450 to or 900 megahertz, right, corresponding to 12 or 34 centimeter in wavelength, 12 or 34 centimeter in wavelength. In this frequency range, the dielectric heating mechanism dominates up to moderated temperatures. Polar molecules, the dominant water, try to align themselves with the rapidly changing direction of the electric field. The energy to achieve this alignment is taken from the electric field. When the field changes direction, the molecule relaxes and the energy previously absorbed is dissipated into the surroundings, that is directly inside the food. This means that the water content of the food is an important factor in the microwave heating performance of the foods, right. So, depending on that is why any dried product where moisture is not there, you cannot heat through microwave, because that water that acts as the heating medium, right. So, the polarity of the water that makes the heating. So, unless you have moisture, then you cannot heat. So, this is one which has to be kept in mind. So, after the microwave heating, there are high hydrostatic pressure processing or HPP. Again HPP, since it has come up, high pressure processing, high hydrostatic pressure processing or HPP, which we come across. Let me also tell about this, that though throughout the world this technology people are trying, high pressure technology, I am not against it, but only the thing that it is very difficult to commercialize it, because the primary is not in terms of quality or in terms of the process, it is primarily the price which is the drawback of this system and may not be feasible for commercialization, right. But of course, we must know the process, that is why I have brought it into this, that high pressure technology or high hydrostatic pressure processing is that the application of hydrostatic pressure to food results in instantaneous and uniform transmission of the pressure throughout the product, independent of the product volume, irrespective of the volume, or it is irrespective of the size, right. So, it is hydrostatic pressure which is affecting the food material, right. This is generally used for inactivation of the microorganisms, right, and without the heat treatment. So, it is the pressure treatment which you are making. So, it is not the heat which is coming across, for which the quality is not getting affected, right. The hydrostatic treatment is unique in the effects do not follow a concentration gradient, nor do they change as a function of time. Other advantages include that the substance of chemical additives and operation at low or ambient temperature, so that food is essentially raw. Liquid foods can be pumped to treatment pressures, held and then decompressed aseptically for filling as with other aseptic processes. Pressures of 650 megapascal, 650 megapascal can reduce the viable numbers of microbes, right. So, primarily this is for deactivation of the microorganisms, and you see the pressure range is around 650 megapascal, right, 650 megapascal, mega 10 to the 6, right, like micro 10 to the minus 6, mega 10 to the plus 6. So, 10 to the 6 Pascal and 650 of that 10 to the times of 10 to the 6 Pascal you need, right. We know 1 atmosphere is 101.321 kilopascal, right. So, that is so many times than the atmospheric pressure. Then pulsed electric field, another very new one which is coming up. High intensity pulsed electric pulse. Pulse means whenever you are giving a little and then stop, a little then stop, like this. This is the called pulse. This way it goes, right. Like our body pulse, you will not get a continuous, right. it gives peak and then this, and the peak and then this, right. So, like that it is. So, that is why it is called pulse. So, pulse electric field is like this. High intensity pulsed electric field processing involves the application of pulse of high voltage, typically from 20 to 80 kilovolt per centimeter, 20 to 80 kilovolt per centimeter, to foods placed between two electrodes. Pulsed electric field treatment is conducted at ambient or subambient or significantly above ambient temperatures or less than 1 second. It is very short timed. As a result of which the energy loss due to heating of foods is minimized. Pulsed electric field technology is considered superior to traditional heat treatment of foods because it maintains food quality by avoiding or greatly reducing detrimental changes to the sensory and physical properties of the food. That is another one which is very, very important, right. Then osmotic dehydration, right. Of course, we know osmosis, right. Osmosis is also again a semi-permeable membrane technology, right, and this is due to the concentration difference. One is high concentrated, other is less concentrated. Depending on that, the movement of the liquid is from one side to the other side. So, that technology is being used here, right. So, osmotic dehydration, and in many cases this is dehydration, that is you are removing moisture from the food material, you are removing the moisture. So, in many cases this is done, right, and in that what we can say is that the concentration of food products by means of product immersion in a hypertonic solution is known as osmotic dehydration, and osmotic dehydration consumes less energy compared to air drying and freeze drying, because water removal occurs without a phase change. There is no phase change because you have a membrane and this water is moving from one side to the other side, right. So, heat damage to the food product is minimum in case of osmotic dehydration, as the product is not subjected to high temperature for extended periods. Successful attempts have been made to dehydrate traditional Indian dairy products such as malai, rasgulla, paneer using osmotic dehydration technologies, right. So, osmotic process is a very, very helpful and useful process for removal of or concentrating the food products, right. Then hurdle technology. This hurdle technology is of course another one, that is where the combination. Hurdle technology is a concept in which 3 or more preservation parameters, that is hurdles, are employed in suitable combination, and even hurdle is used to add optimum level so that damage to the overall quality of food is kept minimum. Hurdle technology has been tried for preservation of several Indian dairy products such as milk cake, paneer and paneer curry, right. So, this hurdle technology, more than 3 parameters, that the hurdles are employed, right. Maybe pressure, temperature and some other, maybe concentration, like that. So it is a combination technology. It is a combination technology where more than one parameters are controlled. So that type of thing where combination technologies are, where temperature high is not possible, so use a little pressure, use some concentration difference. So all these put together, you are crossing the hurdle. So by that you are processing. This is a very good concept, because if you see like walking through narrow space, if you see that this road is not good, so you can use a little for that and change to another. So like that. So it is a combination where according to your requirement, according to your usability, you are utilizing it, right? Then the last one is biopreservation, by which you have already done in many cases. That biopreservation refers to the extended storage life and enhanced safety of foods using their natural or controlled microflora and or their antimicrobial products. The diverse group of lactic acid bacteria synthesize a variety of inhibitory substances such as organic acids, carbon dioxide, hydrogen peroxide, diacetyl, bacteriocin, etc. So, by the organisms you are creating many substances, one or many in combination, which are acting against the organisms. For example, the word which we said hydrogen peroxide. Hydrogen peroxide is very antimicrobial, right? So which prevent the development of undesirable bacteria. So these are some of the techniques which recently have come up, and they are not only used in dairy, but also are used in many other food products, right? So with this, let us complete today, and thank you.